Thank you so much for being here. It's my distinct honor to have this distinct alum. This is going to be a lot of fun. We are going to have rock and roll, and next we have 90 minutes with you, a lot of questions and answers from students, and we'll get started. We have a lot of great wisdom here, and again, it's just our honor to welcome you all. Thank you to Patrick and Ali for the introductions. Also wanted to thank Pierre Bertrand, he's been running videos, questions and answers to all of our astronaut colleagues here, and we're going to put together an archive. You guys are so special that we want to keep you in our halls. We use you for inspiration all the time. For all of our students, for our faculty, your messages are really important to us and inspire the next generation. How many people in the audience are students and want to become astronauts? Who wants their jobs? So that's why we're here, is to get advice and get your wisdom and the inspiration. And we've heard a lot over the last couple of days, been fantastic. A little criticism of NASA, maybe. And I'm here to say they're our nation's greatest agency, and you're all representing it. And so we're just going to have an inspiring session and say, here's what's right, and this is definitely what's right with NASA, all these distinguished people. And we have exploration as a mission. We're going forward. So I'd like to ask, the process would be, I'll ask a question. We're too many to answer, so maybe about 3 of you could answer each question so that we can cycle around and get a lot of questions answered. Then we'll keep the last 15 minutes because a lot of students still even have more questions for you. So about an hour of Q&A, and please, whoever's expert in the area, you can answer. So about 3 per question. Thank you very much. So I'm going to start off with what's maybe the most important lesson you learned from spaceflight?
Right.
Mike thinks so.
So if I answer first, I don't have to answer anymore, right? So going into space and getting to see planet Earth from space, we talked about the moon earlier, but all of us have been really focused on low Earth orbit, although the Hubble guys were slightly higher. They have a Mach 26 patch. We get 25 patches for flying on station. Yeah, you got a couple, right? So
you can't have one, by the way.
Yeah, I can't. I didn't even ask for one. That would be awesome. So we get to see planet Earth, and being a EAPS grad, Earth Atmospheric and Planetary Science. I mean, I love Mars. I love the moon. We got missions going to Pluto and all. It's fantastic what we're doing. But I think one of the things that we've really learned from spaceflight is how wonderful and special our planet Earth is, and how important it is. It's the cradle of humanity. Everything that ever happened in all of history is on this one little blue planet in the middle of the cosmos, and we need to really appreciate that.
Thanks, Mike.
Thanks.
Jeff, lesson learned for us.
2 things. First, on a personal level, and this is for all of you who raised your hands that you'd like to someday follow our footsteps. If you have significant others, wives, husbands, discuss your decision with them before you make it. I'm looking at my wife in the first row. Anyway, on a more, how shall I say, institutional point of view, I think we've learned this lesson a few times, but, well, we've had this lesson a few times. We still don't seem to have learned it. Don't stop flying one space vehicle until you've got another one to take its place.
Thank you. Mike, Massimino.
Yeah, I was just going to add, I've been lucky enough to fly with John twice, and I think one thing I've learned as an astronaut, how important the team aspect of things is. Going into space is really complicated. It takes a huge team to do that, not just the crew, but the folks that train us, the people in the Mission Control Center, and it requires that amount of talent and dedication from a lot of people. So it's a team game, and as Jeff alluded, there's a lot of people with their hands raised. I get the question a lot, what does it take to be an astronaut? And I think it's, you have a certain amount of qualifications you need and background experience and so on to get you qualified. But I think that the other thing is, is this a person you can work with, live with, train with, become a family member with? And that was something I guess I always knew, sort of, but when you go through a training flow together, it becomes really evident. So it's it's the greatest job in the world, not just because you get to fly in space and see the planet like Mike said, but because you get to work with great people, not only the astronauts you fly with, but all the people that in the big program that help you go.
Great. Thank you.
We do one more?
Katie, yes, one more.
So,
Lots more lessons.
A few months on the space station, you wake up every morning hoping that you're ready for the day or that you have whatever you need for the day. And being in this auditorium makes me think about, the late nights, the early mornings, the problem sets where somebody next to you just seems to know it instinctively and you're still on problem number 1, part C. Talking to a professor and saying, this is what I think and this is how this would work out and, so this is what I've learned. And they look at you and say, that's really great. You should probably think about that a little more. So, but seriously, the hard steps that you take here, and they're often when you're really tired and you wonder if they really count. And I would say that going up there and realizing that it all does count. All the times that you're just really smushed down and you have to climb back up and do that problem set, or, you don't get the grade you want, but you still have things to learn and you're going to get there. And, you do all those hard things, and I use what that felt like and the fact that I could pick myself up and do those things. I use that, probably every day in the space program because the things we do are hard.
We do them because they're hard, right? Not because they're easy.
And if they're easy, we don't have to make them hard.
That's true.
You work on that part. So, in the same vein of lessons learned, but what are some leadership skills that you would share, especially with our students in their journeys to take over your jobs?
Well, I think one of the leadership skills that folks often don't think about is good followership. And it goes with what Mike Massimino said is, you have one commander, but everybody has to align behind that commander. You have one team. Everybody has to be aligned on that team. And you'll experience that hopefully soon, that if you have a team and there's one spoiler, the whole effort will fall apart. And so shared vision, leadership, but also good followership. I think good followership is one of the best leadership qualities that astronauts have to learn as they're coming up through the chain. And then if you do get the opportunity to lead an effort, either to be the commander or whatever particular challenge it is, you really do have to think about not just the task, but about how you solve that task, how you engage everyone, so that people have a shared vision. I think that's our challenge writ large for NASA right now, is that we need to have some shared visions and be able to work towards those. Little hint for you.
Ken, please.
I think a couple of the skills that are really important are communication, and you really have to trust. I mean, we talked a little bit about the people you work with. No one person can do everything. In fact, if you think you can, you shouldn't probably be there. You have to recognize that each person is going to be specialized in a certain part of the mission. You'd like to have somebody backing them up at the same time. So everybody's got a piece of the whole mission that's, so to speak, their special part of it, but they've got someone else backing them up on that, and they are backing somebody else up on something else, so that the whole team is engaged in the overall mission, so you don't have people feeling like they're not a full part of it. So you wind up trusting people with your life, and that is the fundamental. We're trusting each other with our lives, and to get that trust, earn it, you really have to have the competence and then the ability to deliver, do what you say and say what you're going to do. So that's part of the team building, I think, is the skills we're really trying to put out there.
Especially when you have to trust, a lot of subcontractors and components, some of which were the lowest bidder.
I'd like to build on that point, is that when you're in space, you really want to make your crewmates be able to do their job the best way that they could do it. So you spend most of the time trying to figure out how can I help my crewmates do a good job, excel in the tasks that they've been assigned to.
I think those are great lessons. Hopefully we're teaching some of those as well as what engineers do. We're problem solvers, teaching about team, trust. Chris wanted to talk,
I was just going to say, an interesting aspect of the space station leadership is cross-cultural or international leadership, where there's 6 people on board, astronauts, cosmonauts, representing all the different 5 partner agencies. And each one of those personalities and cultures brings with it different unique angles and viewpoints on certain situations. So what as me, as just a military guy here in America, might view as the right answer for a leadership challenge might not be the same solution that other guys or folks on the crew would arrive at. So that was kind of interesting for me to observe.
And some particularly challenging parts about that, again, lessons learned for yourself under the cross-cultural?
I didn't quite hear you.
Just any. I just wanted to dig a little bit deeper in terms of the cross-cultural.
Yeah. Well, arm wrestling with a cosmonaut for a microphone in one particular situation, but we won't get into that right now.
Dava, I'd like to add one thing, because it goes to communication, which is what Chris is talking about. And one of the questions you asked is, what was the most valuable courses that you took on orbit or whatever? Well, sad to say, I didn't do any differential equations while I was up there.
Breaks are hard, but you were well prepared.
But it might be surprising that, I mean, studying Russian language while here at MIT was extremely important for what I was going to wind up doing later, personally. And once we took on partnership rather than competition as the goal of our space program, seeing the whole world, as someone said, from space, that doesn't all speak English. And so there's an aspect that goes beyond the technical engineering education that is, how do we take what we know and then communicate it to people to be effective in doing things? So I think that's an important part of the cultural training that Chris alluded to is understanding we have more to learn.
Yeah, thank you. And so such an important point, because cultural understanding, back to helping prop everyone up. Maybe you're speaking English and or Russian, but probably the listening part. Am I communicating? Communicate it back. You know, are we really all doing this together? Jeff wanted to comment.
Yeah, I mean, it's certainly true. We've had cultural challenges with Russians, Japanese, Canadians, and so on. The worst intercultural challenges, though, by far that I saw when I was in the Corps was between the Air Force and the Navy pilots. and then you throw in a Marine or two, and you know.
That's accurate.
Any last word, gentlemen? Lady?
Well, I wouldn't hold it to Russian. You know, we say Russian because those are our sort of major partner, and we're all required to know Russian, and they're required to know English. But in my experience and what we're seeing is that if you can speak some other language, not your own, if you can learn one other language, then you can add on to that. And when we were looking at people, we were looking for that ability to just think outside how you know how to communicate.
Mm-hmm. Great, thank you. Let's talk about the vision. Grand vision. We're celebrating AeroAster 100. 100 years from now, what are astronauts going to be doing? And where will we be? And we can do short answers, because I think we have to get all of you to comment on this one. We want to hear from all of you.
Down the line.
Fish, you want to start?
No, start
Oh,
My answers will be gone. Darn it. So I think that short term, it's important for us, like we are with the Commercial Crew Program, to kind of spark the engine of commercial innovation, and we'll see what they come up with, and I think that's going to be a great leg in the infrastructure that we build. Also to build the infrastructure, which we are with Orion and SLS, to look for those new technologies, like for Matt Asher with new engine technologies, propulsion technologies, radiation protection, as well as getting being able to have a closed system where we can, you know, this isn't exactly like the Pilgrims. We aren't going to a land where there's trees and water and animals and everything that we can support ourselves on. So we have to be smart about it and be able to bring and sustain that. Once we've solved those problems, and I think in going to Mars we will, it really opens the equation up, and it's kind of boundless to what we can accomplish. I think for now, the goal is Mars, and I think that will solve the technology problems that we need to solve in order to take that next step further beyond what probably any of us can even imagine right now.
Can I make a point?
Sure.
Well, it's really wonderful to, to be recognized for being an astronaut, and but there's still something wrong here, because we are only about a few hundred people out of 7 billion people that live on the planet, and if it's always going to be like this, that only a selected few get to fly, that's not right. Mm-hmm. So I think we need to open the space to the whole world. I come from a very small country, developing country, and a lot of young people in the rest of the world are yearning to also fly in space. And so I would like to see that day 100 years from now, when we are not, people are not going to be singled out like this, but space will be a place for just conducting human business and work and live.
Humans, yeah, really off planet.
Completely.
Species, hundreds and hundreds,
Yeah.
thousands or tens of thousands of astronauts.
Exactly.
Chris, would you like to?
I think 100 years from now, students in classrooms will be studying the astronaut version of Lewis and Clark exploring avenues on the Mars surface.
Thank you.
Not sure where we'll be in 100 years from now. We're actually not as far today as when I was in course 16 as I thought we would be. So I think we're not going to be as far in 100 years as I'd like us to be if we don't figure out a way to communicate the importance of it and to motivate either the country or the planet. I know the Apollo guys were discussing whether we do it cooperatively or as a race, kind of national pride competition that we executed in the past. If it's, if you have to explain that it's a good investment of your tax dollar because it churns through the economy, or it benefits life on Earth through all the spin-offs, or if it's just exploring to see what's on the other side of the hill, or it's racing to get there first for national pride. Or maybe it's a combination of all those, depending on who you're talking to. But if we don't figure out a way to effectively communicate the importance, we're not going to be as far in 100 years as I hope we would be.
Mike, we're going
to...
I should add, because there's other personal bio things here. So Tony and Mike were classmates. They got each other through unified engineering, sitting next to next. So for all the students, look who's next to you in unified, because guess where you're going to be in a few years. After a few space flights, right back up here in Kresge Auditorium on stage with your buddy.
Instead of the competition part where it forced you to get there first, it was the cooperative part, and I'm not where we held each other back. I'm not sure which one of the guys.
But we actually even ended up flying together for a while. He came up on STS-119 when I was aboard the station. So I mean, it's really amazing. You never know who you're in your class that you're going to end up spending some really quality time with. So 100 years from now, we're going to be at we're all coming to the 200th birthday of the Aero-Astro department. Please send an invitation. I won't mess it up too much this week. But I honestly think we're going to figure out an economic way to make it quite profitable for us all to be in space, and then we'll figure out what an astronaut means when we actually are a multi-planetary species in the next 100 years. I can't wait to see the 3D holographic video that we're going to have the 200th birthday of the Aero-Astro department. There's going to be the Antonelli moon base right next to the Fincke crater because I crashed in, and but we'll have people, but not a colony on Mars. And this is all going to happen, but there's going to be a thriving space industry. And the only question is, on the lunar basis, is the main language going to be English or Chinese?
Spanish.
Both Spanish?
We probably Spanish.
We have some multilingual for sure. We'll turn to Mike Massimino, but first another fun fact. Mike and I were graduate students here together, so Mike got me through
Mike
got me through MIT grad school.
No, I wouldn't, let's not lie here. David got me through. No, we met the first day of graduate school, 1986.
Oh, we don't have to tell him
Tom
here.
Sheridan's All right, I'm a lot older than Dava, but yeah, so you never know where you're going to end up. So Dave and I were classmates. We sat next to each other at graduation, I think, too.
And I think we sat in the back of the class, if I remember right.
We were in the back of the class, that's right. We won't go any further with these stories. But yeah, we met the first day of grad school and we graduated the same day. And now we're here together. So and she's going to be NASA's, one of NASA's big bosses. So this is all good. So yeah, well, 100 years from now, I think, you know, I'm now no longer with NASA and I'm teaching at Columbia. And when I noticed,
get a job here?
no, they weren't. I don't. Well, yeah, that's another story. What I've noticed with the students there, and I guess it's probably the same here, they're very excited, still as excited as we were about the space program. But now it seems to be a lot more than just NASA. It's this commercial opportunities, and we have Elon Musk is coming. Is that a secret, or they got a special secret or something? Okay. So you got all these smart entrepreneurs, right? Who are now there's a bunch of them that know what they're doing. Apparently, they've made money in other places, and now they're investing their interests, their energy, their money in the space program. So the students that I come across are interested in the space program. Some of them want to become NASA astronauts. Some of them want to work with NASA or contractors, but they're also interested in its entrepreneurship, this growing space commercialization, this industry that hopefully is going to continue to grow. And it's still in its baby steps, right? They're just starting this. So I think it's a very exciting time. And I think that we really need for this to work. Hopefully we're at this point where airplanes were many years ago, and now we have one of the students was saying every 3 seconds we've got an airplane taking off, right? So, but that wasn't the way it was with the Wright brothers, and they started out, right? It's slow. And I think now hopefully we're at this point where these commercial entities will just...
Can you imagine a space launch every 3 seconds?
That would be great.
Every minute?
Right, and so I think that's the hope, that right now we're in this, hopefully we'll look back in maybe just 10 years and look back to this year and the next couple and say, wow, we've really come a long way, and things will take great strides. And so 100 years from now, yeah, maybe we can have that kind of space industry. As Franklin said, it's not just a bunch of lucky people who get to go, but anybody who wants to and can experience what it's like to be there. So I'm hopeful.
Great, thank you. Katie.
Well, we should keep the goals realistic, but I'm hoping in 100 years we have spacesuits that fit everybody. I think we're off to a good start here with Dava, but really the point I'm trying to make is that no matter where we are, there's lots of really small moving parts that are just incremental kinds of things about developing technologies to recycle the air, to have the toilet not break all the time. I mean, these are the nuts and bolts, and they're little tiny things, but they're all really necessary, and yet there's also the larger jigsaw puzzle. And everybody here, and everybody who's at all the schools around the country, they each have a way to attack one part of that jigsaw puzzle, whether it's that you see the whole puzzle and you can figure out maybe the larger picture, what it should look like, or whether you're somebody who figures out how to fit just that piece and that next step of technology. And it comes back to what Tony said about communication, where we really need to communicate the fact that this is hard, that there's a lot of moving parts, and at the same time, if we don't communicate that and the vision of the larger, we won't get places. And those challenges will be the same 100 years from now, because we'll have more places we're trying to go.
Thanks. John, 100 years.
100 years is a long time in the history of spaceflight. And when you look at the student talks that we just heard, there's going to be some drivers. And it's going to start in 2017 with the launch of the Transiting Exoplanet Survey Satellite, which is an MIT experiment, and what Maria Zuber talked about yesterday, the James Webb Space Telescope. By the end of this decade, we're going to have a phone book of Earth 2.0s. Now, these are rocky planets around the nearest stars. And we're going to have as a driver the idea that there is another Earth out there. And so I believe 100 years from now, stimulated by the knowledge that there is another home planet out there that we can live on that's very much like Earth, we will have a telescope that can characterize the atmosphere, and it was shown in a large 16-meter telescope magnetically levitated above its star shade, that will characterize the atmosphere and see, is anybody there? You know, are we alone? We have already been exploring Mars. The first crews to go to Mars will be scientists, astrobiologists, planetary scientists, looking for fossil evidence of life, maybe extant microbial life on Mars. We will have interrogated the ocean of Europa to see if there's life under this 4 billion-year-old warm, salty ocean. And we'll be doing that next decade. That's our current plans, with answers coming back in the 2030s. But I think we will discover an Earth 2.0 within 10 light years of Earth that'll be so compelling that some aero-astro student at MIT will invent the fusion drive that will allow you in a human lifetime to go and visit that Earth 2.0. And then I agree with Buzz Aldrin, a one-way trip. It no longer makes sense to go both ways. And then we'll truly be doing the Lewis and Clark expedition, but it'll be to another planet that we can actually survive and thrive on, rather than just survive on, as we will on Mars. And all of the pieces are in place now and things students are doing here at MIT.
Yeah, based on those great student talks again. A shout out to all the students. I mean, they're leading the future. We're here just to support you and give you our support. Ken, would you like to think 100 years out as well?
I'll try.
Yeah.
Rather than think out, though, I was wondering, when we think about flying in space, I asked a student group one time, you know, how many people were flying in space right now? And one kid raised his hand and said, all of us. And I thought, now that's the one to watch. But there's 7 billion space travelers on this planet. In 100 years, I have no idea how many will be there. But if we aren't using what we know about aeronautics and astronautics and space flight to study the big ship, then the voyage may not be as what we really want. And we may find evidences of life on other planets, and I'd like to think that we're going to find evidence of life on this one in 100 years.
Intelligent life.
Okay.
We'd love to.
Well, I work in Washington, D.C. at NASA headquarters, and I've been desperately searching for intelligent life.
So our exploration becomes inward. Thank you, Franklin. And maybe a little bit, we got to hear about propulsion.
Well,
we have to know where the propulsion's going.
We need better motors.
Yeah, there are two ingredients we need to have a robust exploration program, human exploration program. And one is power, abundant power, and the other one is propulsion. Power and propulsion go together. Until we do that seriously, we are probably not going to get very far. We'll be probably loitering around the Earth-Moon environment for a long time, maybe one flight or two to Mars to say that we actually did it. But I think that would not be a good endpoint. My feeling is that we ought to invest in the infrastructure and the scaffolding that will allow us to make these trips sustainable. They're not now.
Thank you. Jeff, how about you as well? I know you're going to...
Not a contrarian view exactly, but if my dreams were realized for 100 years from now, I hope that we won't be seeing any rockets being launched from the Earth, because I'm a believer in the space elevator. And for those, if there's people here not familiar with the concept, I would recommend Arthur Clarke's book, The Fountains of Paradise. Arthur Clarke has a pretty good track record of predicting things that eventually come true. And what he actually said was a space elevator goes from a point on the equator up to geostationary orbit and even beyond. And instead of the thousands of dollars per kilogram that we now have to spend, even with Elon Musk and SpaceX, it's still very expensive to put things in space. A space elevator using electrical power could do it for pennies a kilogram. And what Arthur Clarke said is, once we have a space elevator, and people are working on it, our carbon nanotube technology is getting to the point where we have materials that's strong enough. People are seriously considering that, and what Clarke said was, when that happens, at that point, humanity will finally become truly an interplanetary species, because we'll be able to do it economically. And it's really unless we can expand the economic sphere of humanity, I mean, I think exploration is great, but right now our economic sphere expands out to geosynchronous orbit with the satellites. But unless we can get large amounts of material up relatively inexpensively, it's going to be hard to go beyond that in a really big way. So that's my dream for 100 years from now.
That's great. I want to turn to a student question. Bernard asked our panelists, I'm going to ask Jeff to take this. What was the ratio of estimated cost per pound to orbit over the entire program, say circa 1972, to the actual cost per pound to orbit in constant dollars over these last decades?
Oh, okay, well that sort of goes back to what I was talking about with the space elevator, because of course the high cost of getting things into space is one of the limiting factors. Well, let's see, I mean, a Saturn V, in current day dollars, I think this is correct, it was probably on the order of about $1 billion per launch if you do the inflation factor, and it could take about, I think, 120 tons, is that about right, into low Earth orbit? So you've got on the orbit of about $10,000 a kilogram, which is pretty much the canonical number. Sometimes it's a little higher. SpaceX says they could go down to maybe a couple of $1,000s a kilogram. I should say one thing with the space shuttle, which was often criticized for not lowering as much as people had anticipated the cost of space flight. The space shuttle, in the actual numbers that you heard from it, was a payload of anywhere around roughly about 50,000 pounds, so 50 ton, 50,000 pounds. So, but the thing to remember is the space shuttle carried all of the crew cabin, all of the environmental control life support system, you know, the galley, the water, all these things on any other rocket would have been considered payload. But on the shuttle, they were just part of the vehicle, and the only thing that was considered payload was what went in the cargo bay. So when you look at it that way, the shuttle's cargo carrying capacity was actually a lot less expensive.
Comparatively. Another student, Emily, thank you for zipping in, asking us this question. But she asked, tough one, as students always do, what do you wish you had accomplished when you were younger that you didn't accomplish?
I'm lucky I got done what I did.
I wish I would have spent a lot more time here studying.
You know, I would sleep more.
Sleep more.
Yeah, I'm serious. I mean, I still probably stay up all night, you know, once a month, and you know, and I'm beginning to think that maybe there's some value in being awake during the day.
Well, there's still things I want to accomplish that I haven't, that I dreamt that I would. You know,
and you're still young.
And I'm still, you know, still planning. So if anybody wants to join, I still want to climb an 8,000 meter peak in the Himalayas. And,
on Mars?
Well, there's plenty on Mars. It's cheating, but you got to get there first. The lower gravity. But I love exploring. I love being out in the mountains, and I like really hard challenges that I'm not sure I can do. And when I was 6 or 7 years old and dreamt of being an astronaut, you know, that was one that I really didn't believe I could do until after Jeff Hoffman was selected while I was here at MIT. And I said, maybe that is something that's, you know, in my future phase space.
Should say John was a Europe student when I was working as a scientist on an X-ray astronomy project.
Yeah. Shortly after that, the wheel was invented, and then cars and space stations and spacecraft. Yeah. But you know, my dream really was to fly in space, and you know, I know for
I think everyone up here, right? You had a role model, and you looked up to Jeff or Sally, Franklin. Does it go for everybody?
Well,
everyone here looked up to
what you'd like to accomplish. I'd like to fly in space. I'm at the end because I'm the new guy. I just have to call out Joyce Light because she's put this entire thing together. If you see the lady over there, give her a big hug. She did a lot of coordination to get even a new guy like me to come, so I sure appreciate it, and I'd sure like to do that.
Thank you. Thank you. Okay, we're going to have some fun. This has already been fun, but it's hard to get everyone at once. I know you're patiently waiting to give your points. So this is kind of a everyone participates type of quick questions. It's an experiment. Let's see how it goes. So I'm going to say, you know, this or this. And nanosecond to think about it. And then our left arm is going to go up for the first response.
Left.
Our right arm is going to go up for the second option.
Oh, this is way too complicated for
This is, and to make it more fun, I think the audience should play along as well.
Can you
Okay.
switch their direction so we can
Yeah, we're
match?
gonna get
Otherwise,
We're going to get
Let's for the audience.
you didn't test this
For the
before,
audience. This is not trying to retrain these guys. For the audience, if you like option A, could you please raise your right hand? Option B, you guys get your left hand.
I need
Just so we don't
I need a
confuse.
kneeboard guard.
I really don't want to confuse these guys. I think you guys can do it.
Isn't there
We're
an
going to
app?
fail another test at MIT is what's going to happen.
Isn't there an app for that?
option A, option
Option B. A, B, exactly. It's going to be a new dance move.
I'm confused.
All right.
There is dance.
Magellan or Shackleton? How's the audience doing? They're both fantastic. Why? How come Magellan?
Oh, darn, you have to
You
actually
can quote him. You can quote him.
I love Magellan. He has
So
one of
do
my
I.
favorite quotes of all time about, you know, extending beyond the shores and the shadowy future. And I thought that he captured the ethos of the explorers. I've always definitely looked up to him and what he represented.
But he didn't get back, and he lost
Hey.
90% of his crew. Yeah, Shackleton got everybody back, including himself.
He didn't go too far. They were stuck in the ice the whole time.
But Magellan did, the mission did succeed. He was a great enough leader so that
I
somebody
don't
did
wanna
come
knock
back,
Magellan.
right?
Fair enough.
And he proved that the world was round. No. I think we knew
Okay.
that.
But it is nice to come back.
No, Shackleton was just an incredible leader of people. He was always the optimist. You know, the fact that he was locked in the Antarctic for 2 years, not just with one ship, but one on the side of the Antarctic that his ship got caught in, but another ship on the other side that was waiting for him that he then later went back and rescued. I mean, the whole story of his eternal optimism, his ability, first of all, to do the logistics. One of the talks was about logistics, and he was a master logistician and was prepared to have a plan, a backup plan, and another backup plan, and looked forward to, what happens if the ship gets crushed, but not necessarily share that with the crew, but let them be part of the decision making. That everybody did survive and everybody, did so well. It just reminds me so much of what we all, have experienced in space, because nothing ever goes as it's planned, and we always do have the backup plans.
I was going to say that the two of them have something in common. They didn't have mission control.
He didn't have mission control, huh?
Which is really usually a problem.
Next one. Star Trek or 2001 Space Odyssey?
No, Star Trek. Star Trek.
It's hard to.
All right, we're split. We're split almost 50-50. How come?
All right, so Star Trek has a great impact on the American and maybe the whole world in terms of culture, and that's why there's such a big fan base, right? But if you look at Star Trek, they had this, I'm thinking what they call the original series, TOS or something. It has to have an acronym. So the original series, you had a charismatic leader, but you also had a multinational crew. Girls were on the crew, and boys were on the crew, and pointy ear guys, and everybody. It was a very inclusive, diverse place, especially for the 1960s, and it inspired all kinds of things that people on the planet didn't know that they shouldn't believe, like communicators that look like cell phones, and all these kind of things. It had for a very short series of only 3 seasons, 99 episodes, the original series has made a big impact on how we think about space and exploration.
I'm a huge Trekkie, and so what Mike said is, I agree with, but I raised my hand for 2001 for a very different reason, which is in 1978, I sat 2 rows from the back in Kresge on that side, and Professor Bose had arranged to have a big Bose sound system installed here, and 2001 debuted, its first debut at MIT on the screen behind me. And it was just such an amazing moment. And I was way back there because I got there early, but there was a long, long line. It was like, you know, the introduction of a new iPhone, you know, and I was worried I wasn't going to get in. And it was just a huge shared MIT experience.
Yeah, that's great. How many folks in the audience have seen 2001 Space Odyssey? And now, if you're a student, please keep your hands up. If you're good for you guys. All right. It's a generational thing. I ask anyone over 60, have you seen it more than 10 times? It's a different question. Okay. Changing genres here. Elton John's Rocket Man, David Bowie's Space Odyssey. You might know that as Major Tom.
Space Oddity.
I don't know the second one.
You don't know Space Oddity?
No.
Everyone knows it. Major Tom? Anyone? We have some musicians up here. Definitely not me.
So I was in space with Chris Hadfield when he filmed his version of Space Oddity, but I love Chris like a brother, but I'm going to throw him under the bus and go with Elton John just because that's a really great song.
Exactly. All very inspirational. Okay, here's another fun one that everyone gets to answer. It's just a fun, quick question. What superhero would you be?
Chris?
Well done, dude.
You know, when crews come back from space, we all have our offices in one building, and there'll be pictures along the hallway that your training team will put up there with little captions and things like that. And it's just a really great way to welcome people back. And when Peggy Whitson flew on the space station, there was a cartoon that said, "Superman wears Peggy Whitson pajamas."
Back to maybe a little bit longer, insightful questions, unless you have more fun questions for each other. But when you're up in space, you can share, you know, what's the most challenging experiment that you had? You know, what was really tough to do out there? You're all MIT grads. You're all alums.
Franklin and I are laughing because we had 2 flights together with the tethered satellite, which is, by the way, one of the reasons I'm enthusiastic about the space elevator, because the tethered satellite was an experiment where we launched a satellite from the space shuttle, but it remained attached by a very thin wire, and we put it out to about 20 kilometers. And it took 2 flights before we actually were able to do that, and we had lots of problems, and in the end the tether broke. But for a while, we were standing there looking up, 20-kilometer wire going up, sort of disappearing into space. It was like Jack and looking up at the beanstalk. It was the most technically challenging thing I think I did in my whole career as an astronaut, because nobody knew how to fly tethers before we started working on it. We basically had to invent all the procedures. It was a fascinating experiment. Unfortunately, we had a lot of problems with it, but that was definitely a challenge. And I think...
Well, it was, he was looking out the window, and I was forward looking at the controls, because I was working in the deployment. And so everything was going fine. We were about almost there, up to 20 kilometers, 13 miles of wire. And then I hear this...
Don't tell them exactly what
this is being videotaped.
Right.
So he goes, whoa, 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 whoa. And I was thinking, well, what is this? Whoa, whoa, whoa. And it took a while, and then the tether broke. So it's just like you're flying a kite, and you know your string breaks. It's pretty bad. So.
I called down at the time. I said, Houston, the tether has broken. We're in no danger. And I got really chastised later by my 2 sons. They said, Dad, you missed a great opportunity. You should have said, Houston, we've had a problem. Sometimes you just don't think of the most dramatic thing to say.
Well, you know, I'd like to answer for Mike Massimino.
Yeah. I was going to call on him, but you can answer
We
for
shared
him.
an experience on the last Hubble mission, May of 2009, where we were trying to repair some instruments inside of Hubble. We're in spacesuits, and we were being asked to take out little tiny number 4 torque set screws, the kinds with the cruciforms that are bent so you can't take them out. And we had a lot of input from review committees, independent review teams, and all these oversight boards that said, don't even bother trying because this is simply too much to ask people to do. And with that, I'm going to hand it over to Mass.
It's too traumatic for me. Keep talking, so we each had I saw some of your tools, by the way, from the ACS repair. You'll see them when you come to New York in the Intrepid Museum. But
My car needs work.
Hubble's coming up on its 25th anniversary, and luckily it's still working despite my efforts. So, but you know, what John's alluding to is that generally on Hubble, and Jeff, of course, went on the first repair mission to Hubble.
And we should probably say something about the whiff pick bolt as well.
On our flight,
On your
that
flight.
you
Well,
made
that I
too
put
tight.
in.
Yeah, we can talk about that too. So, how much time do we have?
We have enough time. This is good.
But generally what we do is we take a big instrument out and put a big new one in to replace it. And on the final servicing mission, there were 2 instruments that had power supplies that had failed. A Space Telescope Imaging Spectrograph and the Advanced Camera for Surveys. And John and his spacewalking buddy, Drew Foystel, were outside for the ACS repair, and Mike Good and I were outside for the STIS repair. And yours went pretty smoothly. Ours, we had, I mean, it was a tough repair, but you performed it well. Go ahead.
So we practiced on the ground a lot doing this repair, and sometimes the tools would break, sometimes the practice repair wouldn't go well. And I think in the course of practicing over and over and over again, we found every possible failure that could occur between tools and the actual instrument. And in flight, pretty much every single one of those things happened on the real day. But it seemed normal to me because that's how we train, and so we had solutions on board. And then the next day, Mike Massimino and Mike Good went out to repair the Space Telescope Imaging Spectrograph, and I kind of viewed Drew's and my task as practice day, because we had some number of tiny screws, 36 tiny screws, some things to cut and cards to pull out. But Mike Massimino had well over 100 tiny screws.
117.
117.
But you're not counting.
No,
and
it worked out.
And that was the hard part. The easy part was first we had to take a handrail off to get access to these tiny screws. And so Mike Massimino went out with Mike Good, Mass and Bueno. It was kind of convenient because you could say, hey, Mass, hey, Mike, get me a wrench, and 2 people would deliver you a wrench. But Mass and Bueno, I don't know why Mike Good was called Bueno. Anybody?
What's that
Anyway,
Spanish?
No say.
Good. Good. He must be. Mike Good. His last name's Good. Bueno.
But this turned out to be the most challenging spacewalk on the mission for reasons we didn't anticipate.
So you think you've seen everything in training. Well, you haven't seen everything in training, but what you have trained is how to solve problems together. I think that's where the teamwork thing comes in. You can't capture every problem, even no matter how many runs you do to practice in the pool. And this fairly easy handrail to come off with these bigger screws with the big power tool had 4 screws to come out, 2 in the top, 2 in the bottom, and then we could do all these fancy things that we had practiced for many years at great taxpayers' expense to fix this great instrument. And 2 of the screws on the top came out, 1 on the lower left came out, and I stripped the 1 on the lower right, and it wasn't coming out. And I was in a nightmare pretty much at that point.
Well,
but they kept me going on the inside. This is where your teamwork really helps, because I don't know if you remember when I came to I don't want to take too much time here, but
it's okay, you gotta get
try
to
to finish.
the fantastic
What happens, I remember
ending.
the teamwork story here that I think we all can appreciate for me was I was feeling really low at this point. And I went to the front of the cabin to get tape and vice grips. Do you remember this?
Yep.
I didn't even know we had tape on the space shuttle. But they wanted me to go get some tape. I'm outside doing this. Well, yeah, we didn't know we had tape on the
In the
outside.
spacesuit that's really hard to work in.
And I'm feeling really bad. And they're trying to get my attention in the cabin.
Yep.
Okay? And I'm thinking they're going to, chastise me for ruining the future of astronomy. And and I look up, because I didn't want to look at them, and they can't really talk because we're hot mics. And I look up and I see a bunch of these characters looking down at me, smiling and giving me thumbs up and okay signs. And I thought they were watching some other spacewalk. But the point is that you guys were telling me we're going to be okay, we're going to get through this. Just hang in there a little longer. And it was pretty much a nightmare that I was experiencing out there.
And I had the camera, and I said, hey, look at the camera, smile.
Right, and you got my, I wasn't smiling, but you did get a good photo. But then what the solution came up was just to rip the handrail off, which was, it was a Sunday, there was a bunch of young engineers up in the Goddard Space Flight Center who sprang into action in the clean room and figured out it would take 60 pounds of force just to rip that thing off, and that was an easy solution. But it seemed like it was an easy solution that I still would never have thought of to this day without that young group of engineers.
It's a very interesting thing, isn't it? When you're, before you launch, they're very, very strict about any of the things that they'll approve for you to do in flight. And I suspect that if you had proposed before launch, we're going to go up and rip off the handrail, there would have been all sorts of safety reasons why, no, you can't possibly do that. But when you're in the you know, when you're doing the mission and the time is limited, it's amazing the sorts of things that we've actually done out there to solve problems.
Not only that, had Mission Control seen the video of them trying to pull it off on the test rig, they never would have let MAS do it.
We saw the video because the thing goes flying. Yeah. So they were really smart, not just to figure out the solution, but not just to say, all they radioed up was 60 pounds of force. They didn't send the videotape with it. So remember that, kids. You guys, Mom doesn't need to know everything, maybe. Is that the lesson?
And then you want to say one thing about the whiff pick bolt?
Oh, the what? Okay, the whiff
pick. Let me finish this first.
Right.
So Mass and I had flown together before I knew Mass pretty well. I knew his psychological state at the time. And one of the most fun parts was to ask Mass on the open loop. They say that you can break it off with 60 pounds of force. Do you think you can do that? And my other thought was, I'm so glad he was a mech-E major at MIT to be able to rip that handle off. All that training.
You want to tell them do we have time for another Hubble story? The wide field bolt that Jeff tightened too tightly?
I tightened it to spec.
I don't know about that.
You just didn't have quite enough.
It wasn't me, it was John and Drew that route.
Yeah. Well, we had a stuck bolt. And, my most, I wouldn't say frightening moment in space, but my most unprepared moment in space was actually on a Mir space mission where I had arranged to call into Car Talk. And I thought it was going to be a social call, but I was on the loop, and the next thing I hear is, next caller, you're on. And I realized that they hadn't told the two MIT mechanical engineering majors, Tom and Ray Magliosi, that I was going to be calling from the space shuttle. I had to come up with a story. And so it was a mechanical engineering story. Well, fast forward to May of 2009, Drew and I are out there, and we're removing the old camera on Hubble and putting in this new, very high-tech, multi-channel infrared optical camera, the super-duper digital camera, to enable Hubble to unravel the mysteries of the universe. And there was one bolt on it, and we couldn't get it undone. It was just totally stuck. And we had a torque wrench set to a specific torque, and it had a torque limiter so you wouldn't break something. And we went through all the options, and it still wouldn't budge. It had been tightened by Jeff Hoffman.
Working with those biceps.
And, for those of you who go to the gym and see Jeff in there lifting weights, you'll know why. No. And he had tightened it with a different tool than we had. It was not our little handy-dandy pistol grip tool.
But also with the torque limiter.
And a different torque limiter. And after the flight, some folks did analysis of the tools. So we don't calibrate the tools just before flight, we calibrate them after flight. And somebody noticed that the power ratchet tool...
No, we have to rewind that. What's the educational piece in that? You only calibrate them after, before flight and after flight.
Before and after. Before and after.
Okay, sorry,
and
I misheard.
Somebody noted that the torque limiter and the power ratchet tool actually was providing too much torque. Wrote a technical note, filed it away because nobody's ever going to need it. Fast forward, 15 years, and we're in flight, and I can't get this thing undone. Drew can't get it undone, and eventually we decided we're either going to get it undone or we're going to break it. And we were able to undo it, fortunately. And then after the flight, somebody said, "Oh yeah, John, I forgot to tell you about this technical report that said it might be too tight." And that was my low point when I thought we were going to break the Hubble, and it was the very first task.
The issue there was on the inside reading them the checklist at the time, and the way this worked is that if you over-torque that bolt, the bolt wouldn't break loose, the drive shaft would break, which means, because you don't want a hole in the telescope, you don't want to pull the thing out and have to get the new one back in. So the old one stays. So the telescope would still work, but all this fancy new, instrument that was going to do what, John?
Unravel the mysteries of the universe.
Unravel the mysteries
So
of the universe. That's what Wide Field was going to do. We wouldn't be able to do that.
And we're still doing
so
it.
it was Drew Feustel without a torque limiter. You like that? Unlock the secrets of the universe.
Unravel.
That was our technical, unravel. Unravel was the technical one. I would say unlock the secrets of the universe. John would give the more astronomically correct one, which was unravel the secrets of the universe. But Drew Feustel had to go with just a straight wrench on this thing, and on his very first spacewalk, and just do the right amount to get the thing to break loose, and it worked. So it would have been.
Of course, we had advertised this as the easiest repair on Hubble.
Yeah, you never know what's going to catch you.
Drama.
Katie, moving to, keeping with space science, but let's move to Chandra. And any challenge in your mission, just to release it and just that experience? I mean, how important is, I mean, it's just, to me, it's a great example of human spaceflight. You're there, you're in control, releasing a great observatory. So human exploration and space science coming together. I mean, it's just such a great example. Yeah, I think in the Chandra
I like to tell people that, you know, we have to know a lot of things. It's not that any one of them is all that hard, but there's a lot of things to know. And I think that when it comes right down to it, you've just been hearing that these are human moments. You know, that these are moments where you have to kind of, you know, you try to bring out the good things that you have and keep the things that are not so helpful, you know, at bay, so to speak. And so the Chandra at the time was it's basically the sister of the Hubble telescope. I usually make disparaging Hubble remarks at this point in time, but Chandra looks at X-rays, and so all the kind of high energy events, like when stars are exploding, when galaxies are colliding, when black holes are sucking things in, they're spewing out X-rays. So it's a really, really important instrument, and people had waited 25 years to have this instrument in space. They knew enough to know that when it was launched, we would want to see what it could tell us. And at the same time, you know, people had waited their entire careers to get this data. And when you're the person who's actually trying to follow the procedure and not screw it up, it's a big responsibility. $1.8 billion, I think, what the telescope was at the time. And what I tell kids when I talk to kids at schools is that, you know, you're going to be nervous, and so you have to figure out how you're going to deal with that before you get to it. And my way of dealing with that is to know that I've done all the practicing that I needed to do. No matter how much someone thought I should do, I need to do how much I thought I should do, the right kind, the right amount. And if you've done all that, then you can put the nervous aside, because you know that you're as prepared as you can be, that all anybody can ask of you is your best. And so you just have to show up that day and do your best and let yourself do your best. It went okay. We're
going very well.
Yeah, it was launched in 1999, and we're having the 15th anniversary of the Chandra, which was supposed to only work for 5 years. And it's based right around the corner here in Cambridge. So it's a really kind of an emotional project for a lot of us. Yeah. I'm looking forward to the anniversary.
Yeah, the Chandra is part of our great observatories, Hubble, Chandra, the Spitzer in the infrared, and the Compton Gamma Ray Observatory. And another MIT alum played a really pivotal role, to do a little bit of a pun, with Compton, and that was Jay Apt.
Jay and Jerry, and again, we deployed the Gamma Ray Observatory from Atlantis, and it was theoretically a 2-year mission, lasted for 10, and they finally got tired of it and brought it down so they became a problem. How do we get a new one when the other one still works? So they actually, but we deployed Gamma Ray Observatory about 4 months after Hubble was deployed. That one had priority as great telescopes go, and they opened the aperture and realized, oh, we have a problem with Hubble. So they were still working to solve the problem with Hubble when we got Gamma Ray Observatory up there, and this is a 35,000-pound satellite, so it's the heaviest thing that we deployed with the arm, and it was a real example of human exploration, humans and robotics cooperating, which I think every one of these examples, in some cases it's fighting recalcitrant bolts, but it's human beings and their robotic devices working together, and the engineers that develop the one and the people that work the others. So the solar panels on GROW expended, that's what we worried about. That's what they practiced. And Jay and Jerry worked on removing one big bolt, held the command and data handling devices in there, and they practiced the one big bolt thing. The antenna boom, which is like a telephone pole that extended from the underside of Gamma Ray Observatory, it's all buttoned up tight for the shaking during ascent. They threw the switches, sent the commands from the ground, and nothing happened. So then they said, in fact, the Draper guys had helped us a lot with the autopilot for the shuttle, because when you pick up something that big with a weak and flexible arm, now you get a two-body problem that they didn't want to get things excited into weird oscillatory modes. And so all the things that the Draper and mission control guys said never do, once the boom didn't deploy and the backup systems didn't work, then they started sending us instructions to, remember that stuff they said never do? Okay, well, try that. See whether you could shake it loose. And we thought, there's no shaking of a 35,000-pound satellite to make this come loose with this wet noodle of an arm. So they brought it, we had to bring it back down to the payload bay. Jay and Jerry went outside, and I was, as the inside guy, my really job was to put their helmets on, make sure they're buttoned up, and sort of nudge Jerry and say, this up. Because they had a real EVA to do later in the mission. And it was really the sort of ground level adjustment. I mean, Jerry just grabbed the thing and shook it, as far as I know. That's all he admits to. And it popped from the stowed launch position into the pre-deployed position. And like a good astronaut, as soon as it stopped being broken, he stopped trying to fix it. And from that, it worked out.
At the time I was at MIT West, sometimes known as Caltech, and my entire research program depended on the Compton Observatory. And if Jerry Ross and Jay hadn't gotten that out, I wouldn't have become an astronaut.
You needed that data.
Katie mentioned the price of some of these things, and I'll just relate, when we were up with Hubble, we did a quick calculation, you know, the cost of the whole Hubble project, and then the cost of the space shuttle, and we realized that each one of us on board was responsible for about $1 billion when you add it all up, you know, $7 billion worth of hardware, and we were responsible for it. So it sort of, you know, makes you realize the seriousness of what you're doing. Not that we didn't realize it for other reasons as well, but there's a lot of money tied up in these things.
And a lot of hopes and dreams and students' theses to be written and data to be analyzed. So we're going to move on to some questions and answers. I know there's probably a lot of folks in the audience, so we'll ask some people to come down. I still have one more as well, but we're gonna turn it over to Rusty. And then some of the students and other folks can please maybe queue up at the mics as well. We'll get through as many questions as we can.
Thanks. I want to let the students handle the questions here, but I wanted to say that this has been an incredible panel. Not so much the questions you asked, but the interaction that we've just seen in this experience in flying in space, and things never go the way you hope they would, in a sense, or at least the way NASA hoped they would, and we end up with these unbelievable situations in which human ingenuity and guts and a willingness to kick it or break it if you have to make it work, save the day. And this is not true just in what you've heard here, but if I look back on Skylab, I mean, Skylab was a $20 billion disaster when it got into orbit. We won't go into what went on there, but it was very similar to what the kinds of stories that we've just heard here. I want to take just a minute to say, does anybody have any thought of what in the hell we're going to do with JWST when something like this happens to the Webb telescope? Where are we going to be, and the kind of ingenuity that we've just heard here?
Well, as the head of science, and prior to that working the James Webb Space Telescope, which is a large 6.5-meter deployable telescope that's going to go out 1 million miles from Earth. And I thought, boy, I'm going to have the authority and the responsibility. I'll just fix that. And we'll put a grapple fixture on it, and we'll make sure there's targets, and at least some robotic autonomous spacecraft can go out there and maybe shake it a little bit and do the minimum that we need. And I found that that's much harder to do than I ever expected. And unfortunately, in that I've failed. But we are going to put targets on it so that at least if something goes wrong, we have the ability to navigate around it. And you know, we don't have a spacecraft that can go out there, unfortunately. So that's problem number one. But I think it's a question of we're doing a grand experiment. With Hubble, we built a spacecraft that was designed to be serviced. It was built as a system with the space shuttle so that we had the entire engineering done so that it would work in principle. And then Jeff and his team proved the first time that it would, and we subsequently went up. With James Webb, we're doing the other far side experiment, which is something that's very complex and can't be serviced. And we're relying on really fine systems engineering to make sure, putting all of the investments, that it will deploy properly. Now, the advantage it has a lot of adjustments that we didn't have on Hubble, and so we're counting on that. But a lot more testing, and I'm very worried about that. I'm very worried about that whole aspect.
So let's turn to even more questions. Please introduce yourself. Tina, you're up, and you can point if you have a specific question. Please let us know.
Thanks, Dava. My name is Tina Srivastav. I'm a Course 16 alum and aspiring astronaut. I was hoping that you would tell us where you were and what was going through your head the first time you were notified that you were selected to become an astronaut.
I can tell you the story.
Good.
It's a good story because it happened right here. I was in the office of Professor Eugene Covert, explaining to him the principles of the Bessemer engine. And he got a phone call. In those days, they were not, wireless cordless phone. So he got a phone call, and I was just sitting in front of him, very big office, and he said, "It's for you." So he handed me the phone. And I picked up the phone, and there was this person on the other end saying that, I had been selected to join the astronaut corps.
Isn't the first question they asked, are you still interested in being an
astronaut? No, he didn't ask.
You didn't get that. Most of us, I think, got that
as
the first question.
But I thought it was a joke because, they play jokes here at MIT a lot, and so everybody knew that I wanted to be an astronaut and I had to apply. So he called, said it was George Abbey, and he mumbles a lot, so I couldn't understand very well. So finally, I began to understand that this might be real, and I got very nervous. And so I began to pace around with the phone in my ear, and so the cord got wrapped around. Then Mr. Abbey said that, he wanted to know if I wanted the job, and it took me a while to realize that I had to say yes.
There's a question there.
And so he said, well, take your time, just give me a call, and here's a phone number to call. And he gave me the number, and I didn't have anything to write with. So I took the pen off of Professor Covert's jacket, and I ripped off his notebook to write the number. And then, of course, I count down and eventually said, sure, I definitely want the job, positively, definitely. And so I handed the phone to him. I told him I had just been selected as an astronaut. He said, well, Franklin, I think your rocket can wait now, and just let me be the first one to congratulate you. And that was the day that changed my life.
Yeah, that's a great story.
Hi, spacewalking. What was it really like, and what surprised you?
When we do a lot of training, a lot of time in the water tank. My first spacewalk was an unplanned spacewalk because we had launched a satellite. This was on my very first flight, and it hadn't turned on, so they sent two of us out to fix it. And I remember opening the airlock, sort of floating out. My stomach was towards the cargo bay because I had to float over to the toolbox. And I remember thinking to myself, boy, this feels just like when we were in the water. And then I got my tools, attached to them, and then I turned over, and there was the earth and the sky, and I said, whoa, you're not in the water tank anymore.
Chris, how was it?
Same exact experience, except then the sun sets, and it gets even scarier because you can't see the ground underneath you. And one funny story about my first spacewalk was I was opening the hatch in the space station airlock, and there happened to be a piece of trash. It was a drink straw that we have on our drink bags that had floated out and somehow made its way, and at that moment in time, it was right by the side of my head, and there was just a little bit of delta pressure remaining in the airlock as I opened the hatch, and that was enough for this drink straw to go and disappear down into the clouds. And I remember gripping really tightly, thinking, I don't want to be that straw. And at the same moment, I thought of Drew Foystel, who had sent me an email when I was in crew quarters the day before launch and says, whatever you do, loosen your grip. That was his whole email. Whatever you do, loosen your grip. And that went through my mind. I loosened my grip, and I was good to go.
Great.
Thank
Michael, please.
Not a question, really a statement. I'm sorry, but a very quick one.
Please.
I flew in space twice. The first time for 3 days, the second time for 8. First time was with John Young. John and I got along wonderfully well together, but at our pre-flight press conference, someone asked me a question about crew compatibility. And I said, look, I want to fly in space so badly, I'll fly with a baboon. And that's okay for 3 days. And
John Young might not have liked
8 days is not much different than 3. But when I think of what you folks have been through, extremely long duration, large crew size, many problems, experiments to be run, tight schedules, day after day, week after week, month after month. The stuff you've done is just magnificent. It's far exceeds anything that we did in the early days. And I'd just like to take my hat off and say thank you for doing it so beautifully well.
Thank you.
Everybody knows who that was, right? Who just
Maybe in the back.
Apollo 11.
Yeah, that photo conference from everyone's hero on this stage, Mike Collins.
All
so
by himself
gracious.
and not even a baboon.
You weren't looking directly at John when you made that comment, were you?
Yeah, that's
And I think that's what's really special for all of us about being here, this week is, having conversations with people like Michael Collins and hearing what it was like for him and what he thinks of the things he's been hearing. It's pretty neat.
That's inspiration. It's generations of inspiration. Rusty's still here with us, Michael. And so it goes on and on, and it'll be passed on here as well. First to Two Fish, the next flyer, right? Next question, please.
Hello. Since you're the boss, do I get that in writing?
Just for the record, this is like being housemaster at Baker House, right? I'm not the boss at all. This is students run everything. We can't do housing. We can't say, no, we're the coaches from the back, right?
It's going to be a lot worse than those students trying to take care of everybody.
But Two Fish, it was on tape. We have it. We'll get it, yes.
Hello, I'm Jim Clark, a graduate of and now a first-year graduate student at of the Aero-Astro department. And you're all talking about your visions of 100 years from now, and we've got settlements on the Moon and Mars, and if of course, to be practical, they'll have to use ISRU and be materially independent from Earth. And if history is any indication, once they have material independence, they may want, some of them or some people in them will want political independence as well. Do you think that our governance and politics and diplomacy are going to need to change to adapt to having nations not only spread out over a planet, but between planets?
Yes.
So, one really good question to answer your question with another question is, what kind of ideas do we have on this planet for how to govern ourselves? It's that good. What kind of planets? What kind of ideas? We have different ways that we govern ourselves on this planet. Some are very conducive to free thought and free speech and freedom of expression and freedom to be all that we can be, and other ones are a little bit more not as good to the people. And but all those are viable on the planet because we have them. So what kind of planetary governments do we want to have out there? Ones with ideals that help human beings, or the other kind? That's part of the question, and that's one reason why I think our country needs to lead us forward, is because we represent a lot of really good things. Now, some things we don't do so well, but as far as a lot of the other governments and ideals that are out there on the planet, I think we represent among the best.
Besides government, though, let's remember, all space governance now is based on some space treaties which were made back in the 60s, when there were really only 2 spacefaring nations. And the biggest thing, although, and everything was done on a nation basis. Well, we've heard a lot about commercial space activities. We'll probably hear some more when Elon Musk talks. And I suspect that once we develop the capability to actually go and start using extraterrestrial resources, our current governance scheme is going to break down. We're going to need a new way of managing what commercial activities do and how the different nations get involved. And so I think this is, it's not even work in progress yet, but it will have to happen sooner or later if we're really going to have an economic sphere of activity in space that's accessible to all the peoples of the world.
Do you think they'll think
Thanks,
we're a
Jim.
hoax on the moon?
See, jump here.
Hi, my name's Zara Khan. I'm a Course 16 alum as well. My question is, a lot of you talked about the commercial activities and commercial partners launching astronauts to space, and also the economics of launching a lot of different people to space. I was wondering if you could comment in that context about the Russian space agencies versus NASA's approach to working with people like space tourists and private companies, and how that's going to play into the future of space and opening up space to more people.
Great question. So we talked about commercial space and then partnerships within government commercial space. Franklin, you want to?
Well, I think that that particular example, they are teaching us a lesson in business. And I think that we're going to see a lot more of that. And hopefully that will be the case. And I think the private sector will be very much involved and all the way out to the moon. In that entire space, all the way out to the moon.
Yeah. Katie, and I think Fish, you guys are working with commercial companies as well.
I've been working with SpaceX and Orbital Sciences and Japanese, Europeans on supply ships. And, again, it comes down to people and making things happen. And we have culture clashes of some sorts sometimes, and just trying to understand each other's cultures. I think this is whether it's a country or a company or individual people. With respect to the tourists, it's easy to say the word tourist, but basically anybody who does these things that we do, these things that everyone here wants to do, has a passion for exploration and thinks it's really important. In my experience with all the people who have bought their own ticket, so to speak, is that they have a mission as well, and it's about the planet, and it's about others, it's about education. I don't know any one of them that has gone up there, come back, and not caused ripples here on this planet.
Thank you.
Hi, my name is Brandon. I'm a PhD student here at MIT. I guess my question is kind of first for Captain Cassidy. So we've heard here about doing things kind of beyond what you think are immediately practical. So you and Luca Parmitano just did Hawaii Ironman, I guess about 2 weeks ago. So what kind of part of your training from being an astronaut, maybe even a SEAL, kind of prepared you for that? And if you go back into space, was there anything from that experience that you think will help you the next time up? Kind of the second part of that was, this actually wasn't all that long after you got back. And I was like, holy cow, actually having done one of these, I was like, that's an incredible acclimatization to overcome and train for something like. So if you could speak to that, I'd appreciate it.
Hey, if I could, at the astronaut office, it wasn't necessarily his training. You know the Chuck Norris things? Those little sayings? In the astronaut office, we use Chris. So he was always like that.
So it was about a year after landing, and our exercise equipment on the space station now is to the point where it's keeping people really, really healthy, both muscularly and bone density wise. So I don't think that it was a huge stretch to do the triathlon, the Ironman triathlon, a year from landing. The first part of your question is, how did the two training aspects relate? And very, very closely, actually. Training for a long-duration space mission is a couple years before you have this big momentous event where you launch and do the mission and come back. And that's on a little bit smaller scale how the triathlon training was for Luca and myself, where this 8-month-long endeavor as we marched toward a goal and then accomplished that goal. So very, very similar. Yeah.
Thank you.
Good morning, I'm Jasmine Mongbellia, a Core 16 alum, currently with the Marine Corps. As astronauts, I'm sure you get a lot of questions about what it's like in space, but Two Fish, you mentioned you're still waiting to go to space. What is life in a day of an astronaut when you're not in space, and you're back at Johnson Space Center?
Well, I am fully qualified to answer that question. So we only have, a couple minutes left, and if you listen in the background, there's kind of a buzz, and you can hear all the hundreds of people waiting outside. Right now, I'm working on the commercial crew program, and you have Elon Musk coming in. I think it's one of the most exciting times, certainly since I've been in the office, to work on that new. It's such a new engine for innovation, and everybody is really excited about the possibilities of broadening the scope and not just the one monolithic NASA program, but we're going down multiple paths. It allows a lot more people to come in with ideas and get to a place where we didn't think we necessarily could before. So for me, right now working on that, especially as a test pilot background, I find it fascinating and very exciting. Probably you can tell from the sound outside, so do a lot of other people.
Thank you. I think we can get one more question in, maybe one or two, please.
Hi, my name is Nikhil Vedhapkar, and I'm a graduate student in the Manned Vehicle Lab. So we know a lot of you based on your accomplishments or public appearances, things like that, but I get the impression that the Astronaut Corps is very much like a family. So within the family, what are you guys known for?
Well, I can find the baked goods on any floor in any building, so.
Mikey, you're known for your good looks.
He's not known for his eyesight.
We're not giving it up.
No. You got to join the family first.
As we count down, okay, I'm going to squeeze in a 30-second.
Morning, everyone.
10-second question and 30-second answer.
Okay.
We have
I'm
big
Giacomo,
flashing
a visiting
lights.
student from Italy. I have a really quick question. I've heard from all of you the technical challenges you have to face, but I'm curious about the psychological challenges that you had to face from the moment you applied till now, even after you retired.
People are always asking about the psychological characteristics that an astronaut needs, and you're probably thinking about, courage under fire or, ability to improvise. I always put patience at the top of the list.
Patience.
So remember that.
I'm working on it.
Patiently working.
6 years of patience.
Thank you.
And not just waiting for your flight, but you've got, if there is a problem, you've got to be able to, sometimes you have to act quickly, but you have to be able to think things through and know what you're going to do. And so, again, patience.
If I know we have 3 students standing up right there, if you take those 3 seats for me, right in the front, I'm going to get back to you. It's been a great morning session. I have to thank our guests. I can't think of anything more fun to do and get the wisdom and friendship and hear from the family. And thank you. We love you guys. We're so proud of you to be, our MIT alums.
Can we stand up, please?
Yeah, of course, for each other. You can stand up.